In the last session of the lesson Structure of the Atom, the objective of this session is to solve typical exercises about the lesson. Before watching this session, you need to prepare the support guide of chemistry, a pen, and a copybook. As a prerequisite, review the summary found in the support guide pages 3, 4, and 5. The first step is to solve individually exercises 1, 2, 3, and 4 in the support guide, and then check your answers page 10. Now open the support guide at page 7 and let's solve the typical exercise 5. The magnesium atom Mg1224 loses 2 electrons and becomes a magnesium ion. Given the relative charge of a proton is 1 plus and the relative charge of an electron is 1 minus. In part 1, it's required to calculate the nuclear charge of magnesium ion. The nuclear charge, as a rule, it is number of protons times the relative charge of a proton plus number of neutrons times the charge of a neutron. Now, the relative charge of the proton is given 1 plus. And the charge of the neutron is 0, so the product here it will be 0. Therefore, we still have to search for the number of protons. In the rule, this part will be 0, so number of protons is equal to Z, which is 12. And then the Q of the nucleus will be 12 times 1 plus, which is 12 plus. Number 2. Calculate the charge of the electronic cloud of the magnesium ion. As a rule, for the charge of the electronic cloud, it is the number of electrons times the relative charge of an electron. It's also given that the relative charge of an electron is 1 minus. What about the number of electrons? We know that in a neutral atom, the number of electrons is equal to the number of protons, so it is 12. After losing 2 electrons, the number of electrons in the ion will be 12 minus 2 equal 10. Therefore, we substitute this number in the rule to get 10 minus. Deduce the charge of the magnesium ion. The charge of the magnesium ion, as a rule, is equal to the charge of the nucleus plus the charge of the electronic cloud. Both of these terms were calculated before, so the answer will be 12 plus 10 minus equal 2 plus. Number 4. Specify if the magnesium ion is an anion or a cation. To remember, the cation has a positive charge and the anion has a negative charge. Q of the ion is equal to 2 plus. Since the ion is positively charged, so it is a cation. Number 5. Write the equation of ion formation of the magnesium ion. Remember that the cation, it occurs in the case of loss of electron, and it is positively charged. We write the electrons after the arrow. Therefore, to write the equation of ion formation, the first step, we draw the arrow. We write the symbol of the atom before the arrow, which is Mg, and the symbol of the ion after the arrow, which is Mg2+. Concerning the electron, they are written after the arrow because this is a cation. So we write +2 electrons after the arrow. Number 6. Represent the nuclide of this ion. The nuclide, as a rule, it is X, A, Z, and N+, because this is a cation. X, it is the symbol of the ion, which is Ng. We write Z, which is 12, and A, which is 24. They were given for the atom, and they remain the same for the ion, and the charge, which is 2 plus. Now, please solve individually exercises 6, 7, and 8 in the support guide, and then check your answers page 11 and 12. Open up the support guide at page 9 to solve the typical exercise 11. Consider the atom of calcium Ca2040. Number 1. indicate the atomic mass of Ca atom. As a rule, the atomic mass is equal to Au. The value of A here is 40. Therefore, the answer will be 40U. Number 2. Indicate the molar mass of this atom. Also, the rule of the molar mass, it is M equal A gram per mole. A here it's 40, so we substituted in the rule to get 40 gram per mole. Number 3. Calculate the number of moles found in the sample of calcium of mass 10 gram. To find the number of moles, we remember this triangle N equal M over the molar mass. M stands for the number of moles, M for the mass in gram, and the capital M for the molar mass in gram per mole. Therefore, we start by writing the rule N equal M over the molar mass. The value of M, it should be in gram, it's given 10 gram. We divide it over the molar mass, which is 40, it is found in number 2, and the answer is 0.25 mole. Typical exercise 12, page 9. Consider the following nucleus designated by the couple ZA. So the given here represent numbers designated by the atomic number Z followed by the mass number A. So if we have 22, 48, 22 it is Z and 48 it's A. This is another atom having Z equal 24 and A equal 53, and so on. Specify the number of elements in this list and indicate the corresponding isotopes. First of all, the atoms of the same element are those having same Z but different A. If we look at the list, we find out that we have 3 distinct values for Z, 22, 24, and 23. Therefore, there are only 3 elements in this list. So, the atom 2249, it belongs to the same element as the atom 2248. Concerning the second part of the question, it is to indicate the corresponding isotopes of each element. We start with the first element having Z equal 22. We have 3 atoms, 2248, 2249, and 2250. The second element having Z equal 23, we have 4 atoms, 2351, 2350, 2346, and 2347. The last element having Z equal 24, also we have 4 atoms, 2453, 2450, 2452, and 2454.